Hi, I would like to introduce standard deviation and variance to you today, and I'm going to do that by first telling you a little story. So here are the scores from a test. In some of the students were in my class, and some of the students were in Miss Sorrell's class. And how about we take a look at that distribution? So here's a nice dot plot of that distribution, and you see the scores are spread out across the way here, all the way from 99 to 64. On average, students got an 84.63. But I'm sort of wondering if there's some difference between Miss Sorrell's class and my class. So I make another graph. This time it shows the spread between it separates my students from Miss Sorrell's students. And I've had to calculate the average for both classes, and they line up exactly the same. So, and I can show you that here as well. 30 students in both classes, and the averages are both the same. So there's no difference in the classes. They're equal classes. Well, you can see from this dot plot that that's not really true, right? There's a big difference between Miss Sorrell's class and Miss My class, and that's in the range of values that we see. In Miss Sorrell's class, the scores are much closer together, and in my class, there's a much wider range. And it's not just the highest and the lowest scores that are giving me that range, it's all over. And so I want to come up with a measurement of how much variation there is in my data. And we have a standard way of doing that in statistics, and it's called standard deviation. So let me calculate that for our two sections here. And you can see the standard deviation in my class is about 10. And then what that means is that if I take every dot in my data set, every score in my class, and calculate how far it is from the average, and take the average of all those calculations, I'll get about 10. Versus in Miss Sorrell's class, I'll get about 4.6. So let's just talk a little bit more about how standard deviation and variance are calculated. Standard deviation and variance are two ways of measuring the spread of a set of numbers. They're calculated by averaging the square of the differences from each number in the set to the mean of the set. So that's a lot of verbiage there. So let's sort of break through that and talk about each little bit. Why the differences to the mean? Why should we measure from the mean? Well, the mean is, in some sense, what we expect to see. And so when something isn't on the mean, that's different. That's the difference we're interested in. So when we take a difference, that measures how far from the mean we get. Why should we use squares? Well, the good thing about using squares is that some of our numbers will be above the mean and some of our numbers will be below the mean. And we would like to measure it so that those two things don't cancel out. So if we square everything, that will work out nicely. But if we square things and everything was measured in inches before, now they're measured in inches squared. And that doesn't seem to be a good way to measure something that was measured in inches before. So we wish there weren't squares. How can we handle that? Well, we can take the square root after we're done with our averaging process. And that's what can be done. So when we deal with, so variance is when we don't take the square root, and the downside about variance is that it doesn't have the same units as what we were measuring before. Standard deviation does have the same units, but we have to compute it with a square root. And so that's not quite as nice. And you'll see here also that I've got 4 equations for 2 different things. Why is that? Well, let me expand out on that a little bit. In populations, when I have all the data, then I can count the true mean and calculate the true variance. And anytime there's a true number in statistics, we tend to indicate that with a Greek letter. So sigma for the standard deviation, sigma squared for the variance. This x here indicates the name of the data set I'm interested in. Over here we have sigma x because we have this square root. Down here these are sample variances and sample means. So s squared x would be the sample variance. And There's one difference in the formula here, this n minus 1. This is because we're using the sample mean to calculate the variance. This creates more error. And by dividing by n minus 1, we actually sort of make it just a little bit bigger because it's possible for us to be a little bit more wrong. And so we don't want to underestimate these variances and standard deviations. And so dividing by a slightly smaller number makes it slightly bigger, and also just makes it a truer estimate of what we think these things are. So I hope that's a nice introduction for you, and if you have any questions, feel free to ask.